Okay, so for the people online, yeah, I guess you can see the overview already. I won't go through it again. So firstly, I'm going to give an introduction to long-termism, which, as I said, is the view that positively influencing the long-term future is a key moral priority of our time. And we can contrast this with a strong version of long-termism, which states that positively influencing the long-term future is the key moral priority of our time, rather than one priority amongst many. And so my kind of quick summary of long-termism is that firstly, future people matter morally. Secondly, humanity's future is potentially astronomically big if we go out to colonize space. Thirdly, that our actions today can influence the far future. And finally, that we should therefore take action to help ensure the long-run future goes well. So Nick Beckstead, in his PhD thesis, which is about long-termism, gives this brief argument for the overwhelming importance of shaping the far future. So he firstly states that there is a non-negligible chance that humanity will survive for millions, billions, or trillions of years. And if this is the case, then the expected value of the future is astronomically great. Thirdly, we can suppose that some of the actions humanity could take would shape the expected trajectory along which our descendants develop in non-negligible ways. And if all this is the case, then we can kind of conclude that what matters most in expectation is that we do what is best for the general path along which our descendants develop over the coming many, many years. And so if we kind of assume points 1 and 3, that there is a non-negligible chance that humanity will survive for a very, very long time, and that some of the actions we could take today could influence the long-run future, then we can conclude that from a global perspective, what matters most in expectation is that we do what is best in expectation for the general trajectory along which our descendants develop over the coming many, many years. So you can note that this is an argument for strong long-termism, but it's obviously also an argument for the weak version. And so we can kind of summarize this utilitarian argument as the expected value or the expected utility of the future is really, really big. And also we can do something about it. So some of the actions that we can take can influence this very large future. So in The Precipice, Toby Ord, which is a seminal work by Toby Ord, who talks about the long-term future of humanity and existential risk, Ord presents several different utilitarian and non-consequentialist arguments for long-termism. And he basically rehashes the non-consequentialist stuff from this book by Scheffler called Why Worry About Future Generations. And I'm just quickly going to outline some of these non-consequentialist arguments. So firstly, Scheffler identifies reasons of interest for caring about future humans. And so the general idea here is that the value of many of our activities depends on the survival of humanity long after we are also gone. So to give you some intuition for this, essentially, a lot of people think or care about being part of something much bigger than themselves and contributing to the greater human project through either science or art. And so secondly, Scheffler kind of highlights reasons of love. And so many people feel this love of humanity, which is kind of analogous to love between individual persons. And we might think that this love is inherently valuable. And obviously people would be distressed because they care about humanity as a whole if it were to go extinct. So this is just another reason that we care about the long-run future or future generations. Then thirdly, we have reasons of valuation. So many of the things that we value besides humans and humanity itself would be destroyed if humanity did go extinct. And for instance, beautiful art and music and funny jokes and things like this. And then finally, we have reasons of reciprocity. And so Scheffler says that we stand in this two-way relation of genuine mutual dependence with future generations. And so the basic idea here is that we kind of have this two-way relationship of I'll scratch your back if you scratch mine with future generations. Essentially, if we positively shape their lives in the long-run future, then they'll be more likely to create a future that is valuable by our standards as well. So I guess I have two comments about these non-consequentialist arguments. Firstly, it's not super clear to me that they kind of come apart cleanly. So for instance, reasons of valuation and reasons of interest seem quite close together. So they both depend on caring about things despite individual humans, for instance, science and art. Yeah, and I also want to say that these, in contrast to the utilitarian arguments, these feel more like like less of an argument that we should care, and more just Scheffler reminding us of reasons that we already do care about the long-run future. So like these things are kind of obvious when you think about them. Like we care about like these things that we value already. So I'll also highlight these counter-arguments to long-termism. So firstly, people might say that we may not have the ability to significantly influence the far future. And so I think this is essentially true for like most people throughout history. But I think it's not true for like some people in special circumstances. For instance, if you're like a global leader with access to nuclear weapons, or the like research lead on like the first project to create superintelligent AI, then I think this is just like trivially untrue. So secondly, even if you accept that we have the ability to influence the future, you might doubt the kind of predictability of our actions, or the unpredictability of the consequences of our actions on the long-run future. And so like a reason, so what I would say about this is that, again, it's probably true for a lot of situations and a lot of actions that we can't predict the consequences of these actions on the long-run future. For instance, like anytime you go to the shops, you might completely change through like changing the traffic. You might completely change which people are born in the future, and this could have like incredibly big consequences. However, I think some actions, and there we like wouldn't be able to predict like if the consequences are good or bad. But again, I think there are like certain actions that are just robustly good that we can predict, like will have good outcomes for the future. For instance, like technical AI safety work. So thirdly, there's this problem of fanaticism, which is that our choices might be dominated by like tiny probability chances to influence like very far future events. And so for me, this is like the most salient criticism of long-termism. And what I would say about it is that it's just not obvious to me how to deal with fanaticism in general, and non-fanatical decision theories are like quite underdeveloped, and it's just like an open problem for philosophy. And also I think that the kind of relevant probabilities here are just not that small. So in The Precipice by Toby Ord, he puts the chance that advanced AI will cause an existential catastrophe at 1 in 10 this century, which is not like a tiny probability. And then fourthly, maybe we just think that like future people matter less. And so I've linked to a paper here on robust temporalism, which is the view that kind of proximity in time kind of always strengthens moral obligations. And the argument for this put forth in the paper is that if you're close to someone in time, then you have like this shared sphere of like influence over the future. And so you have this shared moral burden. And some people might think that this kind of induces special obligations to people close to you in time. For instance, the like obligation to help them or save them. And so this is just one argument, and I'm not sure how convincing you find it. I don't find it that convincing. Yeah, so for more arguments and the responses about long-termism, you can see this paper on the case for strong long-termism by McCaskill and Greaves. And again, I want to say like one more thing about point 1, or the next slide is, again, arguing against this first point that we might not have the ability to significantly influence the far future. So Karnofsky argues that we could be in the most important century of all time for humanity. And so the idea here is that the long-run future is radically strange and unfamiliar, and enough advances in technology could lead to this long-lasting, huge kind of spacefaring civilization, which could be either radically good or radically bad. And also, Karnofsky says that this long-run future could come much faster than we think, and he points to like AI-driven productivity explosions as the cause of this. And we also think, or we have reason to believe, that the kind of relevant type of AI that would cause this like productivity explosion kind of looks like it will be developed this century. And that just makes this century the one that will initiate and shape this very huge long-run future. And although these claims seem quite wild and crazy, we have reasons already to believe that we live in quite a crazy time. So this is just a plot of world GDP over the last 2,000 years. And yeah, I just want to give you some intuition that the modern world is already very strange and crazy compared to humanity's history. as you can see, it looks like we're on this rocket ship that has just taken off. So that was a very quick introduction to long-termism, and now I'm going to talk about existential risk. So I want to make this distinction between existential catastrophes and existential risk. So an existential catastrophe is the destruction of humanity's long-term potential, and an existential risk, or an X-risk, is just a risk that threatens an existential catastrophe, so a risk that threatens to destroy humanity's long-term potential. And these are things such as pandemics, advanced AI, and nuclear war. So I also want to make another distinction between two different types of existential catastrophe. On the one hand, we have extinction, which is obviously just like the total annihilation of humanity, where there are no surviving humans. However, some extinction scenarios might actually not be catastrophes. For instance, if humanity kind of evolves into something better, or digitally uploads, or goes extinct, like at the end of the universe after we've had a fantastic utopian future, or in that case, past. And then on the other hand, we have failed continuations where humanity does survive, but it doesn't kind of reach its potential for a vastly utopic future. And so then again, we can kind of split failed continuations into two different types, where we have, on the one hand, civilization collapse, where, for instance, we have a nuclear war, and humanity survives in some limited capacity but doesn't rebuild civilization. Or, on the other hand, we could have essentially unrecoverable dystopias where the future is very big but very bad. And so this is just like a pictorial representation of this breakdown of existential catastrophes, where we can split catastrophes into either extinction, where everybody dies, or failed continuations, where humanity survives but doesn't live up to its potential. And then again, we split failed continuations into either collapses, where humanity survives in some limited capacity, or dystopias, where humanity survives in a very bad way. So now I'm just going to talk about this thought experiment from Derek Parfit in his book Reasons and Persons. And so Parfit asks us to compare these three outcomes. Firstly, we have peace. And secondly, we have a nuclear war that kills 99% of people, but humanity eventually rebuilds civilization. And then finally, we have a nuclear war that kills everybody. And so clearly, like option 1 is better than option 2, which is better than option 3. But Parfit asks us to consider the kind of relative badness between these different options. And so the first difference is peace versus 99% of people dying and humanity eventually rebuilding. And the second difference is 99% of people dying versus everybody dying. And Parfit argues that the second difference is very much greater than the first difference, because in the second world, humanity's future can be rebuilt, but in the final world, it's just lost forever. And with this kind of thought experiment, I just want to kind of point you towards the intuition that if we accept long-termism, reducing existential risk might be the most important thing we can do. So this is just another breakdown of existential risks that's given by Toby Ord in The Precipice. And so Toby splits the risks into natural, anthropogenic, and emerging, where natural risks are things such as asteroids and supervolcanoes. Anthropogenic risks are risks from humanity against itself, so things like nuclear war and climate change. And then we also have emerging risks, such as engineered pandemics, totalitarian world governments, and advanced AI. And Toby also gives these probabilities that each kind of class of risk causes an existential catastrophe this century. And I'll just point, you can see it on the slide, but he puts the emerging risk at 1 in 6 this century. So that was like a brief overview of existential risk in general, and now I'll talk about existential risks from advanced AI. I'll just stop here and ask if anybody has any questions. And I'll also get some water, because okay. Yeah, so now I'll go on to talk about X risk from advanced AI. And first I'll give some, sorry. Yeah, go on. Are you officially taking this module? Sorry. Are you officially taking this module? No, sorry, go on. Yes. Yes.
have a sense on what advanced AI is correct?
Yeah, so I think I said earlier that it's 1 in 10. At least that's Toby's number. But obviously there's like a lot of disagreement, and Toby is not an AI expert. So yeah. Yeah.
So how did you come to these estimates?
Yes, largely. I think actually he doesn't defer too much to experts and comes up with his own kind of opinions. But obviously he goes to experts for like looking at, for instance, the paths to advanced AI and timelines and things like that. And yeah, then he does some complicated Bayesian calculations is how I think it works. Any more questions? Yeah, so now we'll go over like arguments that AI will be an X risk to humanity, and then I'll discuss like detailed takeover scenarios. So firstly, I'm just going to like explain some terms for advanced AI. So firstly, we have transformative AI or TAI, and this is just AI systems that have a societal impact equivalent to that of the Industrial Revolution. Then we have artificial general intelligence or AGI, which is a AI system capable of behaving intelligently over many domains. And this is in contrast to current systems that are very narrow. Then we have HLMI, which is high level or human level machine intelligence. And this is AI systems capable of carrying out all human tasks and jobs. And then we have Bostrom's superintelligence, which is any intellect that greatly exceeds the cognitive performance of humans in virtually all domains. So I'm going to go over these 3 arguments for AI risk, which have been discussed. So the first is Bostrom's the superintelligent will. The second is Stuart Russell's second species argument. And the third is Richard No's AGI Safeties from first principles, which is essentially just a more precise version of the second species argument. So I'm going to make this distinction between final goals and instrumental goals, where an agent's final goals are those goals which the agent wants to achieve for their own sake, and its instrumental goals are goals which the agent wants to achieve in service of some other goal. And so Bostrom discusses the relationship between intelligence and motivation, and he presents this orthogonality thesis. And so this is the orthogonality thesis is that intelligence and final goals are orthogonal axes along which possible agents can freely vary. And so the idea is that any level of intelligence could be combined in theory with any particular goal. And so Bostrom also has this instrumental convergence thesis, which is that several instrumental goals can be identified which are convergent in the sense that they are very useful for achieving like a wide range of different final goals. And so Bostrom highlights several like key instrumental goals, which we can split into either preservation goals or power-seeking goals. So firstly, we have like self-preservation. So the idea here is that like no matter what goal you have, if you're going to die, then you're not going to be able to achieve that goal. So you have an instrumental goal to preserve yourself, to not die, essentially. And then similarly, we have goal preservation. So if you're an AI and you have some goal, then you don't want to allow your designers to change what that goal is, because then you would do badly kind of with respect to your original goal. And then we have power-seeking instrumentally convergent goals. So cognitive enhancement. If I'm more intelligent, then I'm more able to achieve my goals. Technological perfection. So if I have access to more technology, I'm also more able to achieve my goals. And then resource acquisition as well. So for many different goals that I might have, it's helpful to have a lot of resources. So to kind of summarize Bostrom's argument, we have this orthogonality thesis that a superintelligent AI could basically have any possible different goal. And then we have the instrumental convergence thesis that states that most goals that a superintelligent AI could have would lead to unsafe behavior, such as self-preservation or resource acquisition. And so we can kind of conclude that superintelligent AI is an existential risk to humanity. So now I'll just lay out Stuart Russell's second species argument. And the basic idea is that human intelligence is the characteristic about us, or that we have, that enables our control over the world. So chimps are still the second most intelligent species in the world, but humanity shapes the world to suit what our goals are, and this isn't very good for the chimps. And after the advent of HLMI, humans may only be the second most intelligent species, and the implication is that this would also go quite badly for humans. as it does for the chimps now. Okay, so Richard No then makes this argument more precise in his AGI Safety from first principles. And so he has this 4-point argument where the first point is that we'll build AIs that are much more intelligent than humans. The second point is that those AIs will be kind of autonomous agents which pursue large-scale goals. Thirdly, those goals will be, misaligned with ours. That is, they'll aim towards kind of outcomes that are not good for us. And finally, the development of such AIs would lead to them gaining control of humanity's future. And I'll kind of go through each of these points one step by step. So the first point is that we'll build AIs which are much more intelligent than humans. So I'll say that it seems plausible that this is theoretically possible to do. We would need strong reasons to think that it wasn't possible. And given that we're uncertain, we should maybe not leave things to chance. Secondly, I'll say that there are economic and strategic incentives to building high-level machine intelligence. So DeepMind's slogan is to solve intelligence and then use it to solve everything else. So it would clearly be quite useful to have very intelligent machines. And finally, many organizations are just explicitly working towards doing this, such as DeepMind and OpenAI. And in fact, as of last year, there are 72 known projects around the world working towards AGI development. And I'll say that DeepMind and OpenAI are the main players at the moment, and that industry kind of has a lead on governments and academia. So the second point in the argument is that these AIs, so they're going to be much more intelligent than us, that we're going to invent, are going to be autonomous agents which pursue large-scale goals. And so the first point here is that essentially goal-directedness, what we might call goal-directedness, is a very useful thing for AIs to have. So if you want to build an AI to do something, it's very useful for it to have a goal. And indeed, this is exactly how we build AIs. We kind of choose some goal, some reward function, some loss function, and then we train an AI to optimize for that goal. And yeah, we can also point out that these goals will often generalize to be very large in scope. So they will kind of cover the scope of the entire world due to, for instance, instrumentally convergent reasons. So the third point is that those goals will misalign with ours. So why would we think this? Well, firstly, human values are very complex and nuanced and not very well defined. So in some sense, they're a small target to hit when we're trying to design advanced AI. And there are also lots of philosophical questions that need to be answered before we even understand what it means to align an AI with human values, and indeed to even decide what human values are. And finally, the existing kind of technical tools for shaping the goals of AIs are just unfortunately inadequate at the moment. So the final point in this argument is that the development of these AIs would lead to them gaining control of humanity's future, and they would kind of do this via their superhuman intelligence and technology, etc. And so this point depends on how fast AI development goes and the state of technical alignment and safety work at the time, and how well humans can cooperate both politically and economically. So those were the kind of three main arguments in the literature that advanced AI will cause an existential risk. And now I'm just going to address some common counter-arguments and responses. So firstly, some people might say, don't worry, we can just switch it off. Well, Stuart Russell likes to say you can't fetch the coffee if you're dead. So even an AI that has the goal of fetching coffee will not allow you to switch it off, because then it wouldn't be able to get coffee. So this is just a restatement of self-preservation as a instrumentally convergent goal. So secondly, people say that human level or superintelligent AI is impossible. But as I said before, this is a very strong claim requiring strong evidence. And so I'm reminded of the story of Ernest Rutherford and Leo Szilard, where these are nuclear physicists, and Rutherford said one evening in an interview that nuclear fission was just impossible. And Leo Szilard read this in the paper the next morning and kind of went for a walk and then invented the nuclear chain reaction. So yeah, the point here is just that experts get these things wrong. So thirdly, some people say that it's too soon to worry about. However, the response to this is that timelines are very unpredictable, and also that the technical kind of safety work might just take a long time to figure out. So fourthly, kind of fourth counter-argument is that any machine intelligent enough to kind of be a danger would be intelligent enough to have wise and altruistic objectives. But then we've seen with the orthogonality thesis that any level of intelligence can be combined with any objective. So we just have reason to think that this fourth point is just untrue. So those were the arguments for X risk from AI, and now I'll discuss some more detailed takeover scenarios. So you can kind of split takeover scenarios into misuse, which covers things such as like robust totalitarianism with advanced propaganda, or like AI weapons, and then like terrorism from AI with AI weapons, or like global AI war. Or on the other hand, we have accidents, which is loss of control due to creating AIs with misaligned objectives. And here I'm just going to talk about accidents. Maybe I should stop and ask if there are any questions about the arguments. Okay. Yes, I'm going to talk about different takeover scenarios in which we lose control to AIs with misaligned objectives. And so some of the key variables which we can use to kind of categorize these takeover scenarios are firstly speed. So people make the distinction between fast and slow takeoff. And so the question is just, is there a sudden jump in AI capabilities over a very short period of time? And secondly, we have this uni versus multipolarity. And here the question is there a single AI system that kind of quickly takes over, or many different actors at play? And then finally, we have alignment. So the question here is, what misaligned goals are pursued by the AI systems that are taking over? And are they outer or inner misaligned? And I'll define alignment and outer and inner misalignment soon. So firstly, speed. There are two different types of what people call fast takeoff. And so on the one hand, we have a discontinuity around HLMI. And so this would be like a rapid jump in AI capabilities at some point. And this could be caused by, for instance, a theoretical breakthrough. Otherwise, we have this intelligence explosion. And so here the idea is that there's some positive feedback loop involving AI capabilities that leads these capabilities to grow hyperbolically or exponentially. And so something here that people talk about is reaching a point where AIs are the ones doing most of the AI research, and we kind of hit this point of recursive self-improvement. And so this is just a plot to kind of aid your intuition about these different types of fast takeoff. So in the top left, we just have kind of business as usual increasing capabilities. Then in the top right, we have a discontinuity, but no explosion. So again, this is, for instance, when we kind of make some theoretical breakthrough and very quickly make a lot of progress. Then in the bottom left, we have no discontinuity, but an intelligence explosion where we hit this positive feedback loop. And then in the bottom right, we have both a discontinuity and an explosion. So secondly, we can analyze takeover scenarios based on whether either one or many AI systems are at play. So uni versus multipolarity. And so something we can say about this is that faster takeoff, for instance, a discontinuity, implies that there's only one like single AI system that takes over, that kind of suddenly reaches the kind of required capability threshold and then, takes control. And slower takeoff scenarios suggest a kind of multipolar world. And I'll just briefly say that there are kind of lots of new challenges in the multi-agent case, such as different types of cooperation failures and kind of arms race dynamic scenarios. So thirdly, we can talk about the state of alignment in this takeover scenario. And so I'm going to define alignment like this. An AI system A is aligned with a designer H if A is trying to do what H wants it to do. So this separates the system's incentives from its capabilities. And so the idea being that even if A doesn't always do what H wanted it to do because it's incapable, it at least is trying to do what humans want it to do. And so I also have this kind of silly picture where we have this human H who has goals or preferences theta H, and this human is going to create some loss function L, and they're going to use this loss function L to train an agent A who's going to end up with the goals theta A. And so the outer alignment question is basically the question of whether theta H, the goals of the human, are like correctly captured by the loss function. And then the question of inner alignment is whether the agent's goals like correspond to the loss function. And so more precisely, we can define outer and inner alignment like this. So firstly, I'm just going to say that a system A is outer aligned with the designer H if A's training objective generally represents the preferences of H. And then on the other hand, we have inner alignment, which is a system A is inner aligned to a training process T if the objectives, that is the final goals of A, correspond to the objective function of T. And so I won't talk much about inner alignment here or give many details about anything at all because the talk is really fast and covers a lot of things. But for a more rigorous treatment of inner alignment and an explanation of why we think it might be a problem, you can see this paper on risks from learned optimization by Evan Hubinger. Okay, so as I said, we can kind of analyze scenarios with respect to kind of state of alignment at the time, and we can ask questions such as like basically whether the system is like inner versus outer alignment outer line tells us a lot. For instance, we have this question of warning shots, where warning shots are kind of early failure modes that tell us that something is going wrong. And so I'll say that like in a slow takeoff outer misaligned world, we might get warning shots because, for instance, the system might try to fool the designers by like faking results to get good feedback. And in this case, the agent like actually cares about getting good feedback. It's just that they're like subtly outer misaligned. So like getting good feedback is not exactly what we care about. It's just like a proxy for our goals. So on the other hand, there might be what Bostrom calls a treacherous turn. And so the idea here would be like systems that are what's known as deceptively inner misaligned might pretend to like be optimizing for our objectives until they essentially don't need to anymore. And they just kind of, there's this treacherous turn where they suddenly take control. And yeah, obviously in this world, we would not get warning shots. And so we can kind of infer things like this from the state of alignment in the takeover scenario. So these are some other considerations, but I'm a little bit conscious of time, so I think I'll skip them for now. So these are like other variables that you can, never mind. Yeah, so now I'll talk about some like detailed takeover scenarios. And so these are essentially just like stories that people have written about like AI takeover. And I'll run through them like point by point. So firstly, we have what's sometimes called brain in a box scenarios. So this is the like classic Bostrom-Yudkowsky view. And kind of the way they talk about it is that we're going to be given some AI, super intelligent AI in a box, and just the problem is to give it the correct utility function. And so in this world, yeah, a single like highly agentic AI system just very quickly becomes super intelligent and then takes over because its objectives don't actually capture like exactly what we wanted them to capture. Secondly, we have this story called What Failure Looks Like by Paul Christiano. So the brain in a box scenario is like obviously unrealistic for a number of reasons. And so this scenario is like a little more realistic. So in this world, AI systems kind of gradually increase in capability and they're used like more and more throughout the economy for lots of different tasks. And they actually do like provide a lot of value early on, but their objectives are like subtly divergent from what we actually want. And yeah, they keep getting like given more and more jobs and gaining increasing power of the world. And unlike in the first story, we don't go out with a bang, but we kind of slowly just lose control of the future. Thirdly, there's this story by Andrew Critch called What Multipolar Failure Looks Like. And so this is like quite similar to the previous story, where AI systems are like ubiquitous throughout the economy and military. And this post mainly like highlights multi-agent failure modes in which like multiple AIs or AI human teams like fail to cooperate with one another, and this leads to catastrophe. And as I kind of alluded to before, there are like a number of new problems in the multipolar world because of like race dynamics and like tragedy of the commons type problems and different cooperation failures, essentially. Fourthly, there's this story from Beth Barnes at OpenAI called Risks from AI Persuasion. So here the idea is that like even pre-AGI machine learning systems may be superhuman at persuasion and manipulation. And we can kind of point to like current social media algorithms that are already like influencing kind of Western democracy and like causing people to essentially be like increasingly extremely polarized in their ideologies. And so this is just like what's happening already, but the story is that it gets much, much worse. And yeah, essentially just societal decision-making breaks down and this leads to catastrophe. So fifthly, we have this report by Joel Carlsmith on existential risk from power-seeking AI. And yeah, this report lays out like a very detailed argument that power-seeking AI will cause an existential risk. And Carlsmith like analyzes the incentives to build power-seeking systems. And he also like analyzes the likelihood that such systems will take control of humanity's future and that this will lead to catastrophe. I won't say much more about this because it's a very long report. Yeah. And yeah, then as I said, we can kind of analyze these different takeover stories by these three different dimensions: speed, uni or multipolarity, and misalignment. So like on the left column, we have the scenario. So we have like brain in a box. And here, obviously, the speed is very fast. It's a unipolar world where a single AI system takes over. And the story is that it's outer misaligned. Its objectives are just not what we exactly wanted. Then in the second world, what failure looks like was like in contrast, this slow failure mode where AI systems like slowly increase in power. And there were perhaps multiple like systems at play. And they were like in some way, either outer or inner. The story actually presents two different situations. But yeah, the idea is that they were kind of subtly misaligned, and this just ends up with humanity slowly losing control over the future. And I will, I think, not go through the rest of the table. It's not that interesting. So that was like existential risk from advanced AI. And we talked about some key arguments in the field, and then these detailed takeover scenarios. And now I'm going to talk about what we can do about it. So technical and policy mitigation strategies. Yeah, maybe I'll stop for questions again.
Yeah. I'm wondering if you could just give us some more information about just an example to illustrate how that would work.
Sure. So an example, there are different types of inner misalignment. And like one type that is usually like used as an introduction is what's known as proxy goal misalignment. So the idea here is that you train some AI in some environment and it accidentally learns goals that are like proxies to what you actually wanted. And so like a concrete example is that we train some AI to like navigate through a maze, and it always has these like green kind of exit signs on the maze. And so we think we've trained this AI that like really wants to get out of mazes, which is what we wanted. But actually, we've just trained an AI to like follow green signs. So that is an example of inner misalignment. And then like the more worrying case that people care about is where the AI like implements like an optimization process itself. Yeah, and in particular, people worry about like deception and deceptive misalignment quite a lot. Any more questions? Okay, what can we do about it? Yeah, so now I'll go over like a number of different technical solutions. And again, I'm going to go through these one by one. So firstly, we have agent foundations research, which is work done by the Machine Intelligence Research Institute, or MIRI. And so yeah, as I kind of said previously in the talk, the current machine learning paradigm is like that you choose some goal, some reward function, some loss function, and then you like explicitly create some system that is like optimizing for this goal. And so it seems like this causes a lot of the problems. Essentially, this framework is like not very compatible with producing safe agents. And so essentially the idea here is to rethink our like foundational notions of agency and to find a totally new approach of building AI, which hopefully makes it easier to do things safely. So the second proposal is reward learning, and this is work done by Jan Leiker, who was at DeepMind and now leads OpenAI's safety team, and also a lot of the work at Center for Human Compatible AI at Berkeley is done on reward learning. And so the idea here is that So in like standard reinforcement learning, we have like some reward function and some agent who interacts with an environment and learns to optimize this reward function. And then in reward learning, the basic idea is to also learn the reward function. So we take some human feedback and we train a model to predict the reward based on that human feedback. And then we use this to train the agent. And so then we hope, so this is like explicitly an outer alignment proposal that hopes to like make sure the training objective matches the human's preferences. Thirdly, we have AI safety via debate. So this is a proposal by Paul Cristiano when he used to work at OpenAI. And so the basic idea here is that we want to train two agents in self-play in this debate game with a human judge. And so like a premise of this is that truthful positions are essentially easier to defend in the debate. And again, the hope is that by training AIs in this way, we would incentivize them to like answer questions honestly and give us good, useful answers to questions. So the fourth proposal is iterative distillation and amplification, or IDA. And again, this is proposed by Cristiano. And the general idea is to like iteratively train increasingly powerful systems and to use the current system at each step to help you make sure the next system is safe. Yeah, I'll just say that about this. Fifthly, we have transparency tools. And so transparency tools are like an inner alignment technique. And so transparency tools like allow designers to analyze what an AI system is thinking in some sense. And this is kind of like just obviously a useful thing to have. And it would allow us to like determine if a model is trying to deceive or manipulate us. Yeah, one thing I also want to point out is that a lot of work on transparency probably doesn't scale very well to very large networks. And obviously, we care in the long run about proposals that do scale to transformative AI. So the final proposal, which again is an inner alignment proposal, is to regularize against internal properties of the network. So regularization is this like process of adding a term to the loss function to change which models are selected by a training process. So normally, the loss function essentially just cares about the behavior of the network, and regularization also usually we care about how well the agent performs kind of behaviorally, whereas the idea here is to regularize against internal properties of the network. So for instance, maybe we can identify like internal circuits in a neural network which suggests that the model is being deceptive, and then like punish these in training. So again, we can like identify these key variables for analyzing different proposals. Firstly, we can ask, is it like an outer alignment proposal or an inner alignment proposal? And we also care about competitiveness as well. And I'm here splitting competitiveness into training competitiveness, which is the question of, is the proposed process of producing AI time and cost competitive with some baseline of producing advanced AI, and performance competitive. So would the AI produced by the proposal have capabilities competitive with the baseline? And obviously, if the proposal is not competitive, then like people will just not implement it, because, for instance, if you're a part of some research group that is like developing advanced AI, and you have the choice of either implementing some safety technique or not doing so, if this safety technique is not competitive with what other people are doing, then you're not going to want to use it. So again, we can analyze these proposals by these different questions, where we have, like on the left-hand side, agent foundations, reward learning, debate, IDA, transparency research, and regularizing against internal properties. And then at the top, we have whether it's an outer alignment or an inner alignment proposal, and whether it's training and performance competitive. Yeah, I can come back to this if anyone has questions, but I won't talk through it. So that's like an overview of the technical solution space, and I will quickly talk about the AI governance space. So here I'm just going to define AI governance as the kind of process of bringing about local and global norms and policies and laws, etc., that will affect social outcomes for the development and deployment of AI systems. And then we can also define long-termist AI governance, which is the subset of this work that kind of is motivated by a concern for the long-term impacts of AI. And so like a high-level view of the governance space is that we can split things into either foundational research work or applied work. And so we can like furthermore split foundational work into either strategy research, which aims to identify good high-level goals for long-termist AI governance, or tactics research, which aims to identify plans that will help achieve those high-level goals. And then on the other hand, we have applied work, which is, for instance, policy development work that takes research and translates it into concrete policies. Otherwise, we also have like policy advocacy or policy implementation. And some examples of research, foundational research work are for strategy research, like TAI timelines forecasting, or work on clarifying the sources of AI X risk. So like these takeover scenarios that we've discussed. And then examples of tactics research is this paper on the windfall clause. And the plan here is to develop a tool for distributing the benefits of AI for the common good. And this would hopefully reduce incentives for like race dynamics between different projects working on advanced AI. Here we have some examples of applied work. So on the one hand, we have examples in governmental policy, such as committing to not incorporate AI into kind of nuclear command and control. Otherwise, we have governmental monitoring of AI development. Then we also have corporate policy, which is developing norms for the responsible dissemination of AI research, kind of given its potential for misuse. Right, so that's basically the end of the lecture. And just to summarize, what we've done is we talked about long-termism. We defined long-termism, which is this view that positively influencing the long-term future is a key moral priority of our time. We gave some arguments for and against long-termism. Then we talked about existential risks, which are risks that threaten to destroy humanity's long-term potential. And we talked about existential risks from advanced AI, laying out kind of key arguments that advanced AI will cause an existential risk. And then we looked at some detailed takeover scenarios. And then finally, we discussed what we can do about it, which are like technical and policy mitigation strategies in a sense. So for me, thank you very much. And thanks to Cosmin and Rob for inviting me to give this talk. Any questions?
Just our interest.
Yes.
For you, what's the most compelling takeover scenario? And with this in mind, what would be the most compelling mitigation strategy?
That's a good question. I guess for me, the thing I'm most worried about technically is what I've called deceptive misaligned or deceptive inner misaligned AI. And the reason for that is just that like it seems like a really hard technical problem that we don't really have a good grip on. Yeah, I'm also probably more sympathetic to the kind of slow world going crazy situations than the fast takeoff situations. Yeah. Yeah. What failure looks like part 2. Yeah, which is, yeah. Yeah. Yeah.
Another question.
Sure.
You didn't touch on this, so it might be a bit fast, but
Mm-hmm.
In terms of takeover, how much do you think hardware
Mm-hmm.
is something which limits the possibility of takeover right now, or is it just a matter of if we have the right technology to create superintelligence, we just need to apply the right compute power to get that hardware currently like?
Yeah, so I think like probably if hardware kind of froze now, we could still have like very advanced AI with a lot of like software architectural improvements. And people talk about it as being in this hardware overhang where, yeah, it's exactly this thing of we have already got the sufficient hardware to build advanced AI, and it's just theoretical breakthroughs that need to be made. On the other hand, I also think that like if we had 100 times more hardware, we would have much better AI systems very quickly as well. So yeah, if you are very worried, you could go out and burn all the GPUs, for instance, as like an intervention strategy. Not that I'm suggesting that you do that. Yep.
Yeah, I have a question. It's not so much to do
Yep. Yeah.
I know that there's some work on the sort of more near-term effects of AI on work.
Mm-hmm.
I just wondered whether kind of two communities work on that stuff and then work on this, whether they talk to each other, whether it's approaches.
So I know some papers that, they basically look at the kind of causal incentives that different AI systems have. And for instance, they have, they look at the incentive to manipulate. This is what I work on, is like the incentive that agents have to manipulate us. A lot of this work is also to do with not influencing like sensitive variables in the environment. For instance, like us and our preferences. And this work has also been applied to kind of considerations of fairness and bias, and being kind of causally independent from like sensitive variables in that sense. Did that answer your question? Yeah, but I would prefer if there was kind of more overlap between these two communities. And I think in particular, the long-term AI people are very fair to the short-term kind of problems people. And whereas a lot of the short-term problems people are like, why are you bullshitting about this long-term AI risk stuff? It's kind of sci-fi nonsense. You're just taking away from these real issues that exist today. And I think that's quite a harmful perspective that people have. Am I allowed to swear, Rob? Am I allowed to swear in the lecture? Probably not. Okay, thank you. Okay.
So, in terms of the governance, do you get a sense that the short-term AI safety problems are being considered enough? And I don't know whether the long-term stuff is being considered at all.
So there are like there was a recent there is some very recent work, like end of last year, that came out. I think it's an EU proposal about it is essentially like a proposal for like benefiting the long-term future and looking after the long-term future, and it talks like majorly about climate change, but also about like existential risks in general, and like in particular, and also like AI specifically. So I guess the answer is that I think there is recent work that makes some really good steps forward in for like the rights of future people, essentially.
Yeah, but it's quite a new discussion, honestly. I just don't know how long it would take, given that the timeline is kind of uncertain. Fast data might happen. Translation from research and policy needs to be quite speedy, right? But I don't know how much attention to take to this.
I think you're right. There's some work, but it's hard for policy to catch up. I think if things go really quickly, then policy will be less effective than technical work, I think. Or maybe very extreme policy could be implemented, just like a ban on AI research.
Yeah.
Yep.
You said at one point that when thinking about takeaway scenarios, the faster.
Yeah. Yep.
I can see what you classify particularly. I just wonder, intuitively, I think if you believe in ideologies about competition, I think as it were, competition is good for knowledge and technological process. What's the kind of there's an intuitive argument regardless of looking at there.
Leads to what, sorry? Slowness. No, I think it's the other way around. So I think it's that slowness leads to multipolarity. So, I mean, that would be that's the argument. Rather, if things go very fast, then it's just the case that someone reaches kind of the needed threshold of theoretical breakthrough, for instance, and then just suddenly develops very advanced, for instance, superintelligence. Whereas if progress is slow, then like everybody is kind of working on it at different times, and there isn't an obvious leader who just jumps up in capabilities. But yeah, of course, like what you're alluding to is that yeah, there are like competitive dynamics between AI projects, different projects, and yeah, exactly as I've kind of just mentioned, there are these like arms race style dynamics where people, because the kind of windfall of being the first person to develop very advanced AI is going to be very big, people are in a sense racing towards the finish line, and yeah, incentivized to, for example, like cheap out on safety work in order to make faster progress.
Yeah. Like that's quite a big problem.
It's not ideal.
Missions that we have at the moment, I think just to get it done rather than guessing there's not a lot of they aren't subject to many constraints on how much they can do, what level the AI can get to before they get to be audited in some way. Nothing to stop them doing like really advanced stuff.
Yeah, I don't know. I guess we can like just develop like norms within the AI community that kind of encourage, for instance, not building completely huge language models that are very capable but also very unreliable in a sense. Yeah.
The organizations who are probably, I don't know, I'm sure they're closest to advanced AGI would be Google, Facebook, two organizations which have I understand academics would be very, very keen to ensure the safety stuff, but it's less of a less consideration for them, I suppose.
Yeah, I mean, there's also the question of how do we align like capitalist organizations to our incentive, our goals, right? It's like an analogy, yeah. Yeah. Let me know if you figure it out. Kind of. I'm going to check if there's any questions online. Okay, no questions online. Any more questions from you guys? Oh. Okay, thank you very much.